Okay, this is the apparatus we're going to use to make ammonia. So this is a mixture of ammonium chloride powder and calcium hydroxide powder. The reaction occurs here, and the ammonia comes over there and fills these two bottles up. And we'll tell when it comes out the other end, because it'll make little bubbles, and there's also some phenolphthalein in there. Hello everybody, we're ready to start this experiment. I'm going to start heating the ammonium chloride and calcium hydroxide mixture. You could actually smell the ammonia coming off. Ammonia, contrary to popular opinion, ammonia is a gas. You see it bubbling over there? Yep, that means gas is being produced, right? And then ammonia is less dense than air, and it'll gradually fill those two bottles from the top down. Get a little bit of water condensed in there because that's also produced hydroxide ion. You see that water there? You feel it coming out fast now. You see that? It really is reacting now. Oh, it's starting to turn red. You see it? Okay, now what I'm going to do is disconnect this so that the water can't come back up. Let's just go ahead and heat it just a little bit more. Well, I can smell the ammonia now. I better not heat it anymore. Let's see here. So I've disconnected the tubing, and ammonia is less dense than air. So what I need to do is turn this upside down and then take the stopper out and put it over the glass plate. And I'll do the same thing with the other one. I can smell the ammonia. We are getting ammonia there. Okay, good. It's got water in it with phenolphthalein, and I'm going to take this first bottle here, and I'm going to stick it in there and see if you see anything unusual happening. Are you ready? You're doing it right. You see anything happening? What do you see happening? Is that bottle filling up? It's filling up. How did I fill it and it was upside down? You see that? It's turning a little pink too. Can you see a little pink? Phenolphthalein is not very concentrated, but it's turning pink. You can see it? You have to make some more phenolphthalein solution. Anybody see that fill up? You can see it, can't you? How did that happen? Figure that out in your spare time and then put the answer there in your report. Why it did it that way. I'll give you a hint though. Phenolphthalein is very soluble in water. It's a gas, but it's very soluble in water. And when at the grocery store, when you buy ammonia, it's actually ammonia water. Ammonia is dissolved in water. Okay, we're done with this one, right? Okay, this is the second part of experiment 7. We're going to prepare hydrogen chloride gas, which has the formula HCl, and hydrochloric acid is a famous thing, but it's actually a solution of the hydrogen chloride gas in water. We're going to make hydrogen chloride gas now. So pure hydrogen chloride gas is a gas. We're going to make it by the reaction of sodium chloride, which is in this gas generating bottle here, with the sulfuric acid. And when the hydrogen ions from the sulfuric acid go onto the chloride ions, it makes the HCl. And since it's a gas, it'll come out as a gas. And you'll see effervescence there. And we'll see bubbling over here. Now HCl is an acid, and that's the same beaker we were using in the experiment with ammonia, and that phenolphthalein is pink because it has ammonia in it. And the HCl should neutralize the ammonia and turn that colorless. We'll hope that works. Are you ready to start? Should we go ahead and start? Okay, now we're ready to start. Here is 6 milliliters of the concentrated sulfuric acid, which we're using for this one. and look for evidence of reaction here. See any evidence of reaction? Yes, it's effervescence. And look over here, you see the bubbling occurring. Now the thing is, these bottles have to fill with the HCl, and since HCl gas is heavier than air, these are filling from the bottom up. Then it goes over here, you can't see the gas, but it's filling up there, and when it comes over there, it should start neutralizing the ammonia and turn it colorless when it starts coming out the other end. Might take a little while to do that. It's starting to come out now. You can see the color is starting to disappear, and it's also HCl fumes and moist air, so that's what's happening here now. Is it turning yet? Color is getting lighter. It is getting lighter, no doubt about that now, is there? It's almost, color's almost all gone now. That's good. Just about all gone, isn't it? A little bit of color left. Yeah, it's essentially gone. Now, use more glass plates. Now the thing is, HCl gas is heavier than air, that's why we did it differently. And so this time, when I take the stopper out, I'm going to put it over the thing with right side up. Okay? And then this one, do the same thing. Now the first one, I'm supposed to take over here and put it into this trough of water, right? Now it's pink in there because it has a little bit of ammonia dissolved in it. Now HCl is an acid, remember. Now watch what happens when I do this. You see the fuming there? You see it's filling up? And you see the liquid in the bottle is colorless, so that it has neutralized the ammonia in there. Look at that, it's almost all, and you see the fuming up above it because HCl gas fumes in moist air. Now when I take this out and let it run in there, it should neutralize the rest of the ammonia and the color should disappear completely. The color's gone, right? Is that good or not? It worked. Now what I'm going to do, the last part of the experiment is this. I have HCl gas in here. And ammonia is there, right? And I'm going to turn the ammonia bottle over. If I can get a hold of it, turn it over so that it's the ammonia. If I take the glass plate off, the ammonia will go up. And I'll take the HCl and I'm going to put it upside down over that, like this. Okay? Now when I pull it out, the ammonia should go up and the HCl should go down, but HCl is a gas, is an acid, and ammonia is a base, so it should make ammonium chloride, an acid-base neutralization, but ammonium chloride is a solid. So what happened? Let's watch this. Are you ready? Anybody see that? That's called white smoke. But smoke is the solid particles suspended in the air, and those solid particles are ammonium chloride. So you saw an acid-base reaction between two gases that made a solid. Okay, and that finishes the experiment, I believe. A while, and you see that the solid is settling out now, and that's ammonium chloride. That's the same compound we used to make ammonia, by the way, at the beginning. Now we're making the compound we started with by the reaction of HCl gas with ammonia gas to make ammonium chloride solid ionic compound. All ionic compounds are solids. Yeah, you can definitely see that, can't you? You looking at it from the side, you can see. Yeah, you can see that. It's settling out in there too. That's good. Now, that's ammonium chloride in there. Ammonium chloride is an ionic compound. All ionic compounds are solid, but all ammonium compounds are soluble in water. So this one here, if I add water to this, it should dissolve. See the bottom is settled out? Let's see. You see it all dissolve? See? And all the stuff at the bottom dissolved, didn't it? You see that all right? You did. There's still a little bit of smoke in there, but I could shake it up and we can get more of it out. There's a little bit of smoke in there. And there's a little bit settled out there too. You see that? We can add that and get rid of that. Watch it. See? It's soluble in water. So the only thing we're not dissolving is the rest of the smoke in there, but it is soluble in water.